This presentation is delivered by the Stanford Center for Professional Development.
All right, so with that said, it's time to actually get into our next great topic in computer science. So I'll just leave this up here if you want to write down these numbers for whatever reason. But to wrap up a little bit about one of our last great topics, which was arrays, and specifically multi-dimensional arrays, and I'll just call them multi-dim arrays. And you've seen a couple examples of these right now, but I want to already, right, in the last couple classes you saw some examples of multi-dimensional arrays, but I want to show you yet another example to show in a very nuts and bolts kind of way how funky things get when you have arrays of arrays and you pass them around as parameters in a program, just so you see yet another example to drive the point home. So let's say I was going to write a program to, keep track of midterm and final scores, for example. And let's say the class was smaller than this. So I had at most 100 students because, I was teaching some class like, basket weaving or something. And it's just small, it's cuddly, we all hold hands. So I have some two-dimensional array that I want to have because I want to have midterm scores and final scores, but I want to keep them separate. So I'm going to have one array of midterm scores and another array of final exam scores. But in some sense, what I really have is a two-dimensional array that's 2 by the number of scores that I have as a maximum. So let's say 100 is the maximum number of scores I'm going to have. So I'm going to have a 2 by 100 array, and I'll call this scores. And I'm just going to create this by basically saying new int. And you've seen the syntax before, 2, and this is 100. And these would probably be constants that I would have in a program, but just to save space and save time of not actually declare, public static final int max size 100. So I'm just going to put 100 in there. And as we talked about a little bit before, some particular entry of this grid, right, because this is just a two-dimensional grid, like score 0, 0, is just a single int, basically. But then we talked about this funky thing where we said, hey, you know what? A multi-dimensional array is actually an array of arrays. So a two-dimensional array is an array of arrays. A three-dimensional array is an array of arrays, right? So we could actually think about, well, what happens if I only specify one of the dimensions of the array? So what do I get if I say, for example, scores sub 0, right? That's not one entry, so it's not an integer. That's, in fact, a whole array, right? The way to think about this is I have two arrays that have size 100, right? So we have a little break in there. And so scores sub 0 is this array, and scores sub 1 is this array, and scores is kind of this array of arrays, right? It's really an array that has two elements. So this is element number 1 over here in the heavy chalk line of the array, or element number 0. It's the first element, and here's element number 1, okay? So this thing, the type of this thing, is really an integer array. And that's the funky thing to kind of think about. Okay? So score sub 0 behaves in your program just like if you had declared a one-dimensional array, which means you can pass score sub 0 to a function that expects a one-dimensional array. And that's perfectly fine. What it's doing is passing this element of the scores array of arrays, which happens to be a whole array of integers in itself. Okay? So any questions conceptually about that? All right, so why don't we look at a little code that actually drives that point home. All right? So we'll put this away. Bye-bye, midterm scores, don't save. And we'll come to our friend Eclipse, and we'll say, hey, Eclipse. Oh, we'll get to roulette in just a moment, don't worry. It's all about gambling in this class. All right, so it's not really gambling. All right, so let's say we have a program that wants to keep track of test scores. So here what I'm going to do is I'm going to have a program test scores. Again, we're just going to set the font to be large. It's not a big deal. And I'm going to ask the user for the number of scores. So I'm going to ask the user for number of scores. And whatever the user gives me as num scores, I'm going to create my scores array to be a new array of integers that's 2 by however many scores you have. And you should see this right now, and you should go, but Maron, well, you're missing the declaration of scores, right? This creates a new array of arrays, but where's the declaration of scores? Instance variable. So I want to show you an example of where we have an instance variable that's an array of arrays. So here I declare the instance variable. This just tells me that scores is going to be a two-dimensional array. It has not yet created the two-dimensional array. It has just said, I'm going to have this thing called scores that's going to be a two-dimensional array. I still need to create it. So when my program runs up here, I ask the user for the number of scores, and I actually create the two-dimensional array. I don't need to declare scores, because scores was declared as an instance variable or an IVAR, so it's already declared. I need to create all the space for all the elements of the array. Any questions about that? Hopefully that's clear. All right, so first thing I'm going to do is I'm going to initialize my scores. And here in its scores, all this is going to do is have two for loops that are going to go through and set all the scores in the grid to be 0 to begin with. Now, I told you before, when you declare an array, when you create an array, the values of the array get initialized to be the default value for that type. And the default value for integers is 0. So you might say, but Maron, they're already zeros anyway, so why are you doing this? I'm just doing this to kind of exemplify the point. I could put in a 1 here and just say, hey, everyone starts with a 1 on the exam, right? But we'll just say it's 0. How do I actually think about this two-dimensional array? Well, first of all, I want to think about the rows of the array, and then for every row, it's got a certain number of entries, or essentially the number of columns in the grid. So how many rows are there in the array? If I look at the two-dimensional grid scores, and I say scores.length, and scores is an array of arrays, it tells me what is the size of the first dimension, right? So if scores is a 2 by 100 array, what's the size of the first dimension? It's 2. So scores.length, the way you want to think about it is this is scores. How big is scores? Scores actually is of size 2. Each of the elements of scores is of size 100, but if each of the individual entries of scores, score sub 0 and score sub 1, is an array. So there's only 2 arrays inside scores. So scores.length back over here in my program will, in this case, have the value 2. Okay? So that's going to be my outer loop. My outer loop is going to say, I want you to loop over however many rows you have in your grid is the way to think about it. For every row, how many entries do you have in that row? What I'm going to do is I'm going to say, hey, all the rows have the same size, so I'm just going to arbitrarily pick the first row, because I know there's always going to be 1 row. If I knew there was always going to be 10 rows, I could say score sub 9. But if you're a programmer, they're just like, why are you doing score sub 9? So the general idiom, the way we usually do it, is just score sub 0, because you always know that there's always a first entry in an array, or an array of arrays. So score sub 0, what is that? Score sub 0, I just told you, is a whole array of integers, right? It's this thing right here. So its length is 100 because there's 100 integers in it. So in this for loop, we loop through 100 elements. And so all we're going to do inside here is we're going to set scores I sub j. I is going to vary from 0 to 1 because it's actually going to count from 0 to 2 but not include 2. And j is going to vary from 0 to 99. And so we're going to set all the elements of the grid to be 0. Any questions about that? The syntax just kind of looks funky because here we have scores without a subscript on it. Here we have scores with a subscript on it. And in both cases, we're taking the length. And the important thing to think of conceptually is it's an array of arrays. So when we just take the first length, we're saying, hey, how many subarrays do you contain? It says, hey, I contain 2 arrays. I'm an array of arrays. And when we take the length of the first subarray, we get the actual number of columns for a grid. Okay? And you could generalize this to 3- and 4-dimensional arrays, but for this class, really all you're going to need to worry about is 2-dimensional arrays at most. Okay? So that's going to initialize all the grid to be 0. So that's what init scores is going to do. And then we're going to write out score sub 0 before we do any incrementing. I'm actually going to increment all the scores inside because it's just good to give everyone points. But before the increment, we're going to print out the scores array at score sub 0. So if we look at print list, right, all print list does is this is a really simple thing. It just gets passed an array of integers. It goes through all the elements of that array, right? So we just are calling the array list in this case. So it's just counting up from 0 up to the length of the list and just writing out all the individual elements, 1 on each line. So it's a trivial thing to write. You've seen this a whole bunch of times with arrays so far. But what are we passing to this guy, right? This guy's expecting a 1-dimensional array. What we're passing is score sub 0 here, which means what we're passing to it is just this single entry from the scores grid. We're passing a subarray of the scores grid. We're passing the very first array that's at score sub 0, which means score sub 0 here is a whole array of integers, and that's the type this thing's expecting, so everything's perfectly fine. It may seem weird that we're sort of taking this grid and dissecting it into its individual rows, but the important concept, and I'll say it once again, each one of those individual rows is just an array in itself. Okay? So last thing I want to do besides just printing out the scores, I want to go through and increment the score list. Now here's something that's funky. In increment score list, I'm going to pass in one of the subarrays. I'm going to pass in score sub 0. What does increment score list do? it's expecting an array of integers. It just has a loop through that list, and it's going to go through and just add 1 to every entry in that list, right? Very standard thing you would think of doing maybe with some array of numbers. You just want to go and add 1 to it. And that's all this method is doing. The only thing that's funky about it is when we call that method, we're passing it a portion of the scores grid, which is just the first array in that scores grid. Okay, so any questions about any of this? If this is all making sense, nod your head. Excellent. If it's not making sense, shake your head. Feel no qualms to shake your head. Good, good, good times. So let's run this. We'll be happy. We'll just make sure it's working. I'll give it a small number of scores because it'll be like a tiny wee class. How many, I should just ask, how many people are in the smallest class that you happen to be in, not counting the instructor? Anyone lower than 5? 1. How many people are in that class? 4. That's less than 5. And as a matter of fact, that's all you need for candy. Because 1 is 1 fewer. And that's amazing, right? It's just a class of 4 people. That's a good time. Sometimes, all right, so we'll say the number of scores is 4 just to emulate your class. And everyone started with a 0, and then they all got a 1, which in a class of 4 people probably means 100%. All right, so that's all it's doing, right? And all of this is in terms of score sub 0. Scores sub 1 has the value 0. It still maintains the value 0. We never touched it when we were doing the incrementing. So any questions about that? No? All right. So besides just doing life, in this array way, you can also do things in the array list way. Okay, so we talked about arrays and array lists. So here I'm just going to have a single array list of scores. And what I'm going to do here, just so you can see the syntax, is again, I'm going to have a private instance variable that's my array list scores that's an array list of integers. I only have 1, and I'm not asking the user how big it needs to be, right? Because array lists are dynamically sized. It doesn't matter. As the user keeps giving me scores, it's just going to get bigger and bigger. So I don't need to have a size a priori. So in my instance variable, I actually not only declare scores, but I actually create the array list. So I create a new array list. It's empty to begin with. I can just add stuff to it. Not a whole lot of excitement going on there. What do? I'm still going to ask the user for the number of scores. But here, when I'm initializing my scores, I don't need to worry about creating an array of a particular size. Here I just say, hey, you gave me some number of scores. You want me to initialize this array with however many scores you gave me. So I'm just going to go and do a for loop and add that many elements to the array list. Because every time I add, the array list just automatically grows in size to be able to store all the scores. And I'm going to store zeros. Well, as you know, a priori, right, 0 is just an int. It is not an integer. So in Java 5.0 and later, because life is happy for us now, we get this automatic boxing, which means the computer sees the 0 and goes, oh, that 0 is an int. Your array list stores integers, right? That's the parameterized type of your array list. So I'm automatically going to box up your little 0 like you're at the integer restaurant, right? And it's like, oh, I got this O. And it's like, yeah, I can't eat the O. Let me box it up for you as this thing called an integer, and then you can have it. And then it says, oh, I can add an integer to scores, and it just takes care of that for you. Okay? So init scores just goes through and adds that many zeros to the list, and then we can write out the scores before we increment. We'll print list our scores. And all print list does is you've actually saw this exact same code last time. It has an array list. We don't need to specify the parameterized type here. This will just work on any kind of array list. It goes through up to the size of the array, and it gets each of the individual elements and prints them out. Okay? So all we're going to do now, the interesting part, is to increment the score list. Here again, we're going to go through scores up to the size of scores, but the syntax looks different. The syntax is actually a little bulkier than our array syntax, so we could just say scores sub, I plus equals 1, right, to add 1, or plus if we just wanted to add 1. Here, the funky thing, if we want to set a score, is inside the scores list, we have to use the set method. There's 2 parameters we send to the set method. The first is the index. So we're going to say set at location I. So whatever the old value was, we don't care. We're just going to slam something new over it. But set something in place I. What are we going to place at location I? We're going to get whatever was previously at location I, which is an integer. And we're going to add 1 to it, which means if I have this thing that's an integer and I want to add 1 to it, I take that integer, I unbox it to become an int. This happens for you automatically. So I get the int, which is a 0, which is what I put in there before. I add 1 to it, so now I have the int 1. And now I want to store it back into something that stores integer. So it automatically gets boxed up for you as this integer and gets stored back. So the syntax looks a little bulky, and that's really the point of showing this to you, is sometimes using array lists is going to actually be a bulky thing to do. But if we go ahead and run this, we're running. Life is good. it chugs along. I got to get a faster Mac. Alrighty, test scores with array list. And it's going to ask me for the number of scores. We'll say 3 this time because someone in your class dropped. And we had 3 zeros that got entered to begin with, and then we went through, and for each one of those zeros, we sort of took the 0, added 1 to it, and stuffed it back in. So we got 3 ones. Not a whole lot of excitement going on there, but you see the difference. So when you see these two things, one natural question that kind of comes up in your head is, OK, Meron, I sort of see 2 ways to do this. Which one should I use? Should I use an array list, or should I use an array? And as a matter of fact, you just told me on this next assignment, I'm going to be working my array muscles. So what's a good idea to think about? Okay? And here are the pros and cons. So if we think of array lists, and I'll just give you the pros and cons relative to array lists versus arrays. The pros of an array list, right, or that the biggest pro is that it has this dynamic resizing. So if I need to add more elements, if I don't know the size a priori, this is a great way to go because it automatically resizes. Okay? And the other pro that it has is there's a bunch of high-level operations that automatically supports, things like contains, right? So you can just see if an array list contains a particular element or not. So it has other operations, I'll just say ops, that are provided for you, right? Which is a nice thing to have, so you don't need to worry about going and finding some element in an array. It does have some cons, though. And the cons are that it's less efficient in terms of how the computer actually deals with an array list versus an array than an array. So it's less efficient than an array. The other con that it has is its syntax can get kind of bulky. Syntax is bulky because one thing that I really want to do often is if I want to have some array, I want to make some modification to the values in that array. Well, in an array, I just say, hey, you know, I have score sub 3 and I stick in some value and life is good, or I say score sub 3 plus equals 5 and I add 5 to it and life is good. Here the syntax is bulky because I need to say get the old value, do the modification to it, and then set it as the new value. And so I'm really doing 2 method calls every time I want to get and set a value, and that's just bulky. And bulk means it becomes more error prone. The other thing is in the pre-Java 5.0 world, so we'll just say pre-5.0, which would make you sad and weep, and if you run into any friends that are using a version of Java earlier than 5.0, you should just pat them on the shoulder and take a moment of silence with them, and then I wouldn't say slap them around, but I would say encourage them strongly to get a newer version of Java. Pre-5.0, this was horrendously bulky to use because all that boxing, unboxing stuff didn't happen automatically. And you had to worry about, oh, I need to box and I need to unbox. It was a bad time. The main difference, and you might say, yeah, well, you know, I don't care about efficiency, right, Marin? I got a whole bunch of memory and my computer's fast. And yeah, bulky syntax, I can deal with that because I cut and paste anyway. And I'm using Java 5.0 or later, so I don't really care about any of this, man. I'm going the easy route. And the real big difference, the thing to keep in mind for one versus the other, is if you know the size of your array beforehand. If you have a fixed size, almost always go with a regular array, not an array list. Keep that in your mind when you're thinking about the program that you're going to be writing. Fixed size. There's a lot of things for which you know they will have a fixed size or some maximum size. Let's take a moment to think about that. Fixed size, your next program, array. Good? All right. So just in case it wasn't clear. All right. So now with that said, it's time to actually move on to the main topic for today. So any questions about array versus array list? Hopefully that should be clarified. All right. And you should just be thinking right now, oh, Meron.
That was easy.
Can you even hear that?
That was easy.
Yeah, that's what I'm talking about. That was easy. Broadcast in stereo. All right, which means it's easy from 2 different sides. So now, the thing to think about is our friend debugging, right? Which is something you've done this whole time, and you're like, but Meron, I've been doing debugging this whole time. How can we have a whole lecture on debugging? Well, because it's time to think a little bit about the zen and the art of debugging, and actually a bunch of practical tools I'm going to show you to do debugging with. Okay? The first thing to think about debugging is when you are a computer programmer or a software engineer, or in the larger sense, computer scientist, there's different roles you play when you are building software. There's a portion of your time which is spent on designing software, and here you're really like an architect. You're kind of looking at big pieces and how they fit together and drawing schematics and figuring out what your sub-pieces are and doing decomposition and the whole deal. Then you go into coding. And when you're coding, you're an engineer. Woo, woo, you got your little hat on, you're in your train. No. You're writing code and you're thinking about good software engineering, but you're building something and you're driving a process forward. Then there's this thing called testing, which you do to your code. And a lot of times that means it's 4 a.m., you think your code works, the project is due tomorrow, and you decide, hey, I'm going to do some testing. And this is the role that does not get taken seriously because it's 4 a.m. and your project is due. Oftentimes testing means, hey, I ran it once, maybe twice, and I felt good and I stopped. And I tried the simplest possible cases I could try. That's not the role you want to play when you're testing. When you're testing, you are the vandal. And that's like you got the spray can in your hand and you're like, yeah, we're going out. You're thinking about what do I need to do to break this program. You're not thinking about what's the least I can do to please make the program run once and get through and hopefully there's no bugs and if it makes it through once, I'll just believe it's correct and that's a good time and I'll turn it in. You're just banging on the thing until you break it. As a matter of fact, a lot of software companies, most good software companies, have people who this is their whole job, right? They don't do this. They get code from other people and just try to break it. And this is a skill. You see some amazing things that people do to break code, but they do it, right? And you got to appreciate that because when you're writing your paper on your word processor at 4 in the morning and it crashes, this person wasn't doing their job because you found the crash and they didn't, okay? So that's what you want to think about. You really want these people to be vandalizing the software, okay? And then after the vandal comes along and smashes everything up, then you have this job that's left to you, which is debugging. When you're debugging, you could think, well, I'm the police officer and I go and track down the vandal and make them stop. In fact, no. You want the vandal to keep vandalizing. You're the vandal. You got to keep trying to break your software. But at the same time, you're a detective to try to find out where the breaks are happening and how to fix them. Okay? Now, here's something that people find a little odd, and I like to call them the four, well, some people don't find them odd. The people who do software engineering don't find them odd. I like to call them the 4 Ds of software. Okay? And the first D is design. You've already seen that. And then there's development, which is actually writing your code. And then there's debugging. And then anyone know what comes after debugging? You're like, D party. No. Deployment. Okay? And in this class so far, we focused on design and development. And now we're going to spend some time thinking about debugging. And deployment is kind of like when you give it to your section leader. We don't worry about like you release software version 1.0 of your Hangman program. And then we're like, oh, so when is 2.0 coming out? And you're like, let me get back to you on that. And then you issue a press release and the dates slip and shareholders get angry. Right? Yeah, like we should have cs106a shareholders. We're like, when is Hangman coming out? Oh my God, you slipped the deadline. Right? Then you'll know how serious those late days are. Then there's deployment, okay? And the one thing that I would posit, and actually a lot of people agree with, is that any problem that cascades from one step to another causes a factor of 10 times in the cost to fix it, okay? Which means you come up with a bad design for something, you're going to spend 10 times as much time writing the code for that bad design. And the bugs that come up as a result of bad design are going to be 100 times as costly to fix. And once that software gets shipped out into the field and the only way to fix it is to issue a new version, that's 1,000 times more expensive. And people look at this and they're like, but Maron, you can't be serious, right? How could it be 1,000 times more expensive? Well, let me give you a little example. How about our friend the space shuttle? Right, we have a space shuttle mission going on. Space shuttle had an initial set of software that was written for it, okay? Right, we're thinking like, oh, like int x. How much do you think one line of code cost when they were all said and done? If you think of the total amount of money spent on the software development effort for the space shuttle versus the number of lines of code that were written, how much did it cost per line of code? Anyone want to venture a guess? Like dollars. $10. That's kind of fun. That's probably a job I take. Anyone want to venture another guess? $1. Higher. Does that scare you? Does that scare you? I take that job. I'd be like, $1,000 a line? Yeah, today, int x. Tomorrow, int y. Right? Like, I'll take that job. That's the right number. Okay? There was about 500,000 lines of code, and now there's more, but in the initial version of the space shuttle, and it took a total cost of $500 million to develop that software. Okay? So this is serious, right? This isn't something where we're like, yeah, it's fun, and we're vandals, and we're debugging, right? When you're on the space shuttle, you better hope someone was doing their job doing this, right? Because if something's wrong, you can't fix it up in space, right? In space, no one can hear you scream. Well, if you're in the movie Alien. But if you're on the space shuttle, it's real difficult to actually fix software. Okay? Mars rover was actually lost because of a software issue. Not actually, well, it was a software design problem that came up, right? Anyone know what the design problem was? Yeah, it was basically two different, it was all basically the same difference as feet versus meters, right? One person was coding to a spec that said, oh, the input you're going to get is in feet. Another one thought it was in meters. Right? Those are off by a factor of 3. That's enough to kill the project. And guess how much money was spent on that thing? A lot. All right? So it's important to think of this well. So how do you actually think about doing good debugging? So the way we want to think about debugging is, in some sense, it's a river. And you're like, what? What is Marion talking about? This is a river. This is the river of your program flowing. Right? It's just nice. It's wonderful. And you're like sitting there and you're having a picnic down here and the sun is shining and the birds are chirping and you're like, if my program gets here and life is good, everything's just fine. But what happens when the river is flowing? You run your program and you get all this sewage down here. And you're like, having a picnic next to sewage is no fun. Well, what happens? So you go all the way upstream and you look at the beginning of your program and you say, well, at the beginning I knew I had no bugs because my program didn't contain any lines of code. And somewhere along the way, as my program's running, there was, say, this factory that was belching sewage into your water stream, which showed up at the end when you were running your program, and this thing is a bug. And oftentimes the problem is there's not just one. If there was one, you'd be like, oh, I can find it. That's all good. Yeah, there's like factories all down and up the river. There's some on the other side of the river. There's some in the middle of the river. Right? It's a bad time. So how do you find those factories that are belching sewage? So here are some things to think about. First of which is the mindset of what tends to cause bugs. Okay? There's 3 things. I wouldn't say they cause all bugs, but they cause the vast majority of bugs. One is bad variable values. Okay? Somewhere in your program you have a value that is not what you expected, and as a result your program is doing something that it shouldn't do. What that tells you, if you think about this mind frame, is knowing the values of your variables at different points in your program is critical to understanding when the bad values entered your water supply. Second of which is faulty logic, right? You meant for the computer to do X, you programmed the computer to do Y, right? X and Y were not the same. There's no such thing as a computer glitch. The computer does what you tell it to do. And so you might say, hey, the computer's not doing what I told it to do. Yeah, it's doing exactly what you told it to do. You just didn't tell it to do the right thing. And last but not least, and this is probably the biggest one, is unwarranted assumptions. Right? Hey, I thought the value were going to be meters. You didn't tell me they were feet until after the mission launched and we lost the rover. Think about what your assumptions are, and that's why when we talked a long time ago about pre and post conditions, right? When we talked about in the little world of Carol, and oh, we just didn't want him to walk into a wall, that was what assumptions were all about. What can your method assume when it's called, and what can you assume after your method's actually done, and do those match up? So the things to keep in mind, and these are part of the zen of programming debugging, and then I'll show you the actual doing of debugging, okay? People have a tendency to look for complex problems. Most of the problems are simple. So don't fool yourself into thinking a problem always has to be complex to be a bug. Sometimes it's just a very simple piece of faulty logic, or some value that you mistakenly added 1 to or added 3 to somewhere that you didn't mean to under some conditions. Okay? Be systematic. There's a tendency, and this tendency tends to increase as the amount of time left to the deadline for the assignment decreases, which is to just haphazardly jump around code and be like, it's got to be here somewhere. Is it over here? No, that's the game I play with my 1.5-year-old son. Is he over here? No, is he over? And he's just standing there with his hands over his eyes. Because he has the simple idea in mind, and I'm looking for something complex, but I'm not being systematic. I'm just like, is it over here? Is it over here? And then finally at the end, right, had I just started at the beginning of my program and began to trace it through, I would have found my problem. But I have a tendency not to do that. And part of the reason I have a tendency not to do that is that I make assumptions about where the problem is. Now, hunches are great. It's great to think about, oh, I think the problem should be here, and have some intuition and hunch about that. But when you have an intuition versus a fact and the two collide, this is in your 11 rules of debugging on one of your handouts that you get, the fact always wins, right? Your hunch never beats out a fact. So if you make assumptions about the problem and you don't see the problem in the place of the code where you thought the problem should be, maybe the problem's not there, and you need to reassess your assumptions about those pieces of code that you thought were simple and so they were error-free, and in fact the error could be there. Okay? Other thing is, be critical of your code. Right? People have a tendency to look at some function or some method and they think, oh, it's super simple, there can't be an error there, or they just glance over it. I've actually seen at major software development companies very large pieces of software written by brilliant, top-of-the-line software engineers who the problem in their code was this instead of this. Right? It was harder for them to find that bug than to find issues with like memory and garbage collection and leakage and all this other stuff, because they were just used to that. Right? They weren't critical of things like this. And when they finally saw this error, you could just see like their eyes just nearly pop out of their head and their head was going to explode. But that's all it was. It was something simple that just the code, they glanced through that code 1,000 times and couldn't find it because they just didn't look at it critically. Okay? And last but not least, and this is the important thing, at 5 in the morning when your program is not working, remember this. Trust me. Don't panic. Panic is the worst thing you can do with bugs. And why? Because people sit there and they think, oh my God, there's this bug in my program and it's over here. No, it's over here. No, it's over there. No. Your code's not changing unless you change it. If you have a bug in your code, there's a bug. It's in one place. It remains in one place. Every time you run your program, it's in that same place, just begging you. It's like, come on, come find me. Did he find me now? No. Come on, come find me. It's just there. It's that same little line of code, right? How many total lines of code are there? Like a couple hundred at most, right? It's in there. It's not moving. It's up to you to find. Don't panic about it. Be systematic. Question your assumptions. Be critical of your code, and eventually you'll get there. But if you panic, you won't, because you won't be seeing it. Okay? So what are some approaches we can take to debugging? Now that we have some of the basic sort of philosophy down. And the fact that the real critical thing is don't panic. The simplest approach to debugging is something that's called printf debugging. And printf is actually something that comes from the language C. The way you can think about it is println debugging. And the basic idea is, right, if bad values are the problem with your program, which in most cases they are, put some extra printlns in your code that tell you what the value of your variables are at different places in your code. Use printlns to let you know that you called a particular method. So at the top of a method, just have a println that says, hey, method X just got called. And right before that method's supposed to be done, you add another println that says, hey, method X is just about to finish. And if you notice some problem that happens between those lines, probably something's going on in method X. Another thing you can do is just write out the values of your variables. And that's probably the thing I would recommend most. At different places in your program, just stick in printlns and see, is the values that you expect there matching what you thought was going to actually be, right? And if they're not, you can sort of see at what point did the variables change to values that you didn't expect. And so something bad must have happened between the last time you saw the values that were OK and the time in which they became bad. Okay? The other thing, and this is a little bit more involved but not a big deal, is something called unit testing, right? People have a tendency to test their entire program at once. They write the program and they run it and something doesn't work. Well, why not actually test out individual units or individual methods in your program, right? Write a call to a particular method where you pass in the values for all the parameters with known values and see if the thing that it gives you back is what you expected it to do. That's called unit testing because you're just testing one unit at a time. And when you're done doing the testing, you can take those calls out and run your whole program. But when you write some method, especially if it's a complicated method, just write a couple of lines at the top of run that the first thing they do is call that method to see if it's actually doing something reasonable with some artificial values that you give it. Okay? So one way that you can combine a lot of this stuff is if you happen to be working in a development environment that gives you facilities to do debugging more easily. And so I'll show you, if we come to the computer, Eclipse actually has a very nice debugging environment. Okay? And so rather these printlns you can do sort of in any program, right? Because even if you're doing a program that you don't have a nice debugging environment, you can still do println and life will be good. So let's actually debug a program using the debugger in Eclipse. So here's a little roulette program. And the way roulette works is we're going to have some constants to begin with, how much money you start with, and how much you're basically wagering or betting on every spin of the roulette wheel. So the way roulette works is we have a big wheel that we spin. And here's all the rules of roulette down here. I'll just show you the rules. Oh, it's too much text to read. The basic idea is the wheel has a bunch of different numbers on it from 0 to 36, all sort of consecutive numbers. And the way you can bet on numbers is you can either bet for an odd number to come up, an even number to come up, a high number to come up, which means a number in the top half, from 17 to 36, or a low number to come up, which means from 1 to 16. And you might, or 1 to 18. You might say, but Marin, what about 0? 0 is always a loser. So 0 doesn't count as an even number. It doesn't count as a low. It's just always the losing value. And the reason why that exists is because that's the house's advantage. It gives them a slight advantage of about 3% over the player, and that's how in the long term they make money, because 0 is always a winner for the casino, never a winner for the player. Other than that, everything's even money. If I bet $10 on low and a 5 comes up, which is in the low half of the range, then I win $5. Okay? So that's what the instructions basically say. Just a bunch of printlns, they write out instructions. Okay? We're going to have a random number generator, rgen, that's an instance variable that just generates random numbers, and it gets an instance of the random number generator. Hopefully after, breakout and hangman, this should be fairly comfortable to you. And now we kind of come to the rest of the code. Okay? First thing I'm going to do is set the font to be big. I'm going to write out the instructions, and then I'm going to play roulette. And so I say, hey, in playing roulette, I have some starting amount of money that the user gets. As long as their money is greater than 0, I tell the user you have some amount of money. I ask them which betting category they want to bet. That means either even or odd or high or low. So they type in a string. There's 4 betting categories. I spin the roulette wheel to get a value between 0 and 36. And then if there's a winning category based on the outcome that they have, I basically say you won this amount, and I increase their amount. If they didn't get a win in that winning category, then I say the number is not basically, that number is not whatever you bet, so you're going to lose. And I subtract the amount of wager from the total money, and if they happen to get out of this loop, then their money is down to 0, and I say you ran out of money, and we stop. Okay? So I might just run this program and see what's going to happen. Notice I didn't show you all the other code yet, because I want to show you the facilities of the debugger rather than just having you stare at code for a bunch of time and try to debug it, because that's not the way you want to debug by just staring at code. You want to look at what the symptoms are. So here we're going to run roulette. And it writes out all the instructions, and it says enter betting category. And so we'll say, hey, I'm going to bet even. Ball lands in 33. That number is not even, so you lose. I'm like, OK, I'm going to go for even again. Good old even. Even always wins. Number 35, you lose. I'm going for even again. 27, you lose. Even, come on. 9, 31, 15. And then you're like, I had so much faith, I lost all this money, and then the ball landed in 2, and I still lost money. And you just kind of sit there, and you're like, yeah, this casino is not really what I had in mind. And you try to leave before the bouncers get involved. But you realize you actually have a bug in your program, right? You bet on even, the ball landed in 2, that should be an even number, and you still lost money. So then you think, okay, something's wrong. What's wrong? Well, let me figure out, right, this winning category thing. I should have said if the outcome modded by 2 or remaindered by 2 is equal to 1, that should be odd. And if the remainder after I divide by 2 is 0, that should be even. So I would have thought this would have been the case. What's going on here? And so what I can do in Eclipse is I can set what's called a breakpoint. The way you set a breakpoint is at a particular line over here on the gray bar, you click twice. And if you click twice, notice I got that little circle there. Can you see the circle on the very edge of the screen? That's called a breakpoint. That means if I run the program now with the debugger, my program will stop at that point and allow me to look at like values of variables and other kinds of things. Okay? So I set that breakpoint by double clicking, and now I need to run again. So the way I run again is, see this little bug up here? That means run with the debugger. See up here? It looks like a little tiny bug. So I click that to run with the debugger, and now it starts rerunning my program again. And it says enter a bet. So I say even. And it says this kind of launch is configured to open the Stanford debugger perspective when it suspends. Should I open this perspective now? Right? It looks all big and nasty, and you just say yes. Okay? And so it says, hey, your program got here. Look at what values you actually have. And so there's a couple things to look at. Up in this debug window up here, it shows me, remember when we talked about stack frames? This is what's called the call stack. The run method called the play roulette method, which called the is winning category method, which is where I'm currently suspended. So it tells you all the functions that are currently, or the methods that are currently active to get you at your current point. Over here in the variables window, it actually tells you the value of the variables. So my bet is even, outcome 13. I say, it says the ball lands in 10. I thought that was supposed to be even, and I was going to get even. What's going on? Over here it tells me that my outcome, which is the thing that I'm going to mod or divide by 2 to see if it's odd or even, is 13. That's not what I got. Which means at this point, sewage has entered the system. The value that I thought I should have is not the value that my program actually has. Okay? So what am I going to do? There's two things I'm going to do. First of all, I want to say, I'm in this debugging perspective. How do I get back to the little editor that's my friend? You come to the Stanford menu and you pick switch to editor. Okay? That takes you back to what you're used to. Notice we're still stopped here, but you're back just in this editor view. There's a couple things we're going to do. First thing we're going to do is I'm just going to say, whoa, stop the program, something bad is going on. Next thing I'm going to do is say, hey, my program involves random numbers. So I'm going to set the seed for my random number generator so I can count on always getting the values the same every time. So if you're debugging with something that involves random numbers, set the seed before you go into debugging, and that'll guarantee you always get the same number. So I set the seed. The other thing I'm going to do is say, hey, the number that got printed on the screen was different than the number that I actually got. So let me look at the code that prints a number on the screen. So here's spin roulette wheel. The ball lands in, it generates a random number, and then it returns a random number. What's the problem here? Anyone want to venture a guess? They're not the same random number, right? It generates one random number to say, hey, the ball lands in some number. That was kind of a social. And then it says, hey, you know what? Yeah, our casino, we just remove that ball, and we just pick another number randomly to say that's what it really was. Okay? That's maybe a lot of fun for the casino, not so much fun for you. So what we really need to do is inside here we'll have something like spin, and spin is going to be whatever we get from the random number generator. Okay? So we'll just say, hey, spin is this random number, and then what we're going to write out is spin over here, and what we're going to return is also spin. So we only generate one random number. Let's save that, and we're like, oh, we only generated one random number. That must be the bug. I must be done. Oh, yeah, good times, good times. So I run my program again, and I get this whole thing, and it says enter betting category, even. 27, you lose. I'm like, oh, it must be working. Even 15, I'm like, oh, yeah, my program is so good. I'm such good, yeah. And you think you found your bug. And then you realize when you're the vandal and you're trying to see if that error condition still exists, hey, we found one bug, that was great. That didn't solve this problem. So you say, okay, back to the drawing board. Let me quit out of here. I'm going to go and set another breakpoint over here. Okay? So let me clear this breakpoint. I'm going to set another breakpoint. I'm going to run it with the debugger, okay, which is what I didn't do before. So now I run with the debugger. And it says enter a bet, and I say even. And it says you've stopped here. And so yes, I want to do this debugger perspective. And I say, hey, the outcome is 27. And so if I look at my bet is not even, right? It should be odd. So I say, oh, that's great. Well, it shouldn't be odd, so that shouldn't match. There are some tools up here I can use to say step through my program. This one in the middle up here, if you can look at this line that has sort of this curve to it, that means step over. And all these different icons are actually explained in your debugging handout, but step over is the critical one. It says, just execute this line of code and go down to the next line of code. You have two other options. You have step into, which actually makes a function call or method call if you happen to be in a method, and step return, which says step out of the current method I'm in. They get a little funky, so step over is what we're going to do. So we step over. And odd doesn't execute, and you're like, yeah, odd shouldn't have executed. Even, yeah, my bet is even, right? I know over here my bet has the value even, so I execute another line. Whoa, what's going on there? I should have gotten bet was equal to even and return the fact that my outcome was actually true, that I actually won. What's the problem here? Pardon? Ah, strings. These are strings. I can't use equal on strings, right? It just doesn't work. It doesn't work when you're not looking either. So I say, hey, come back to the editor. And when you want to make some changes, yeah, instead of checking for equals, I actually need to say dot equals here. As a matter of fact, I'm going to use equals ignore case because that'll make the life for the user even better. They can either put in odd or even in uppercase or lowercase. So I'm just going to do a little copy and paste, which is always a dangerous thing to do. So close. And then for high. And at this point, I could go ahead and save. Oh, it's still in this perspective. I want to quit out of my program. And now there's one final thing I'm going to do here. Let me switch to the editor, and I'm going to run one. Let me save and run one last time. And this becomes very subtle. So if I say, hey, I'm going to bet on odd. Yeah, look, I'm winning now because I know that odd numbers come up. I should have remembered this from last time because I set the seed, right? And I keep betting on odd. And then one interesting thing that happens is 0 came up, right? This is something that may take a while to come up. So I start betting on even. Because I lost with 0 before. It's going to take me a while before 0 might ever come up again, but I need to persevere. And it's probably not going to come up in this run. So let me quit this and run it again. Even, and I should get the same sequence of numbers. Even. Oh, I lost on 0, right? There's one subtle bug that still remains in my code, which is for the case for even, I not only need to check for even, I also need to make sure that the value is not equal to 0. So the other final thing I need to put in here is and outcome not equal to 0, okay? And then my code is actually fixed. So sometimes it may take me a while to find the actual error in my code through running, but now you can use the debugger to find it. All right, and if there's any questions, I'll take them after class. And you can pick up your finals over from, or your midterm exams over from Ben.